The primary architect of early cosmic structure was not ordinary matter, but dark matter. This mysterious substance does not interact with light, but it exerts gravitational pull. Dark matter was far more abundant than normal matter in the early universe. Did this fact catch your interest and you want to know more? Nothing could be easier. Just keep watching to find out. How did the first galaxy form? The universe is a tapestry woven with billions of galaxies, each a majestic island of stars, gas, and dust. From our own Milky Way to the most distant observable spirals, these cosmic cities define the large-scale structure of the cosmos. But how did these magnificent structures first come into being? This fundamental question has long captivated astronomers and cosmologists. Understanding the birth of the first galaxies is key to unraveling the entire evolutionary history of the universe. It takes us back to a time when the cosmos was vastly different from what we see today. Immediately after the Big Bang, the universe was an incredibly hot, dense, and uniform plasma. It was a featureless expanse, too hot for atoms to form, with matter and energy inextricably linked. This era, known as the Cosmic Dark Ages, lasted for hundreds of millions of years. As the universe expanded, it cooled. Eventually, electrons and protons combined to form neutral hydrogen atoms. This crucial event, called recombination, made the universe transparent to light for the first time. Despite its apparent uniformity, the early universe was not perfectly smooth. Tiny quantum fluctuations, amplified by cosmic inflation, created minuscule variations in density. These subtle differences are visible today in the cosmic microwave background radiation. These slight overdensities, though initially imperceptible, were the gravitational seeds of all future cosmic structures. They represented regions where matter was ever so slightly more concentrated than its surroundings. The primary architect of early cosmic structure was not ordinary matter, but dark matter. This mysterious substance does not interact with light, but it exerts gravitational pull. Dark matter was far more abundant than normal matter in the early universe. Its gravitational influence began to pull in surrounding dark matter and ordinary gas. Over vast stretches of time, these slightly denser regions grew into immense, invisible halos. These dark matter halos acted as gravitational wells, forming the scaffolding for the first galaxies. Within the densest pockets of these dark matter halos, primordial gas began to collapse. This gas, composed almost entirely of hydrogen and helium, cooled and condensed under its own gravity. As the pressure and temperature rose, nuclear fusion ignited. These were the universe's very first stars, known as population the 3 stars. They were massive, hundreds of times the mass of our sun, and incredibly luminous. Their lives were short and violent, burning through their fuel in just a few million years. When these colossal population the 3 stars died, they did so in spectacular supernova explosions. These explosions scattered the first heavy elements, such as carbon and oxygen, into the surrounding gas. This enrichment was vital for the formation of subsequent generations of stars. Some of these early supernovae also left behind stellar mass black holes. These black holes, along with the remnants of the first stars, became the initial building blocks for larger structures. They provided additional gravitational anchors for gas and dust to accumulate. As more gas flowed into the dark matter halos, it cooled and settled into rotating disks. These nascent structures, often called protogalaxies, were still relatively small and irregular. They were the embryonic forms of the grand galaxies we observe today. Gravity continued its relentless work, drawing these smaller protogalaxies together. Mergers were common in the early universe, as these young systems collided and coalesced. Each merger added more mass, gas, and stars, fueling the growth of larger galaxies. The intense radiation from newly formed stars and the powerful winds from supernovae had a profound impact on their surroundings. This feedback could either blow gas out of a galaxy, inhibiting further star formation, or compress it, triggering new bursts of star birth. Over hundreds of millions of years, this complex interplay of gravity, gas dynamics, and stellar feedback shaped the evolving galaxies. They grew in size and complexity, forming the spiral arms and elliptical shapes we recognize. Modern telescopes, like the Hubble Space Telescope and especially the James Webb Space Telescope, are peering back in time. They are observing light from galaxies that formed just a few 100 million years after the Big Bang. These observations provide crucial insights into the conditions and processes of early galaxy formation. These distant, faint galaxies appear as small, clumpy, and often irregular systems. They are the direct descendants of the very first protogalaxies, offering a glimpse into the universe's infancy. The formation of the first galaxies was a monumental step in cosmic evolution. It transformed a relatively uniform universe into the structured, star-filled cosmos we inhabit. It laid the groundwork for the formation of planets, and ultimately, life itself. While we have made incredible progress, the story of the first galaxies is still being written. Scientists continue to refine their models and gather new data, pushing the boundaries of our understanding of the universe's earliest moments. Thanks for watching. We hope you enjoyed this video. If you did, don't forget to hit the like button and subscribe for more mind-blowing facts.